Hello, hello. So what we're going to do in this brief little video is just one sort of wrinkle that can happen with the factoring by grouping. Remember, factoring by grouping is only for 4 terms, but we're going to see what happens if the numbers get a little outlandish or a little tough to work with. So our EQ is how can I factor by grouping if there is a GCF, which might seem silly, but you'll see what I mean in a second. For a quick warm-up, all we're going to do is factor out the GCF from each trinomial. So just find what is, remember, when we say greatest common factor, that letter C in that word common means it has to come from every term. Okay, so these 3 terms, what do they have in common? Well, the coefficients are 5, 10, negative 10, really, and positive 25. Those can all be divided by 5. All 3 terms have the variable x, so I'm going to include that. And I can only include x to the first in my GCF because 25 only has a single x to give away. So here I put what's left over if I divide by 5 and take one of the x's away from each term. So 1x squared is what the first term will become. Negative 10 becomes negative 2 with a single x. And then instead of plus 25, this becomes plus 5. Okay. Then we could keep factoring, but all I want to review is just a little finding GCF. Okay, so then here, if I, with these 3 terms, 11, 7, or negative 7, and 9, numerically have nothing in common. There's no common factor for those besides 1. So I'm going to put 1, and then I can take x to the second from all 3 of the terms because the smallest power I see in the problem is 2. So then I have, if I divide by 1, the number won't change, but I'm taking away 2 powers of x. So this becomes 11x squared minus 7x to the first, or just 7x, and then plus 9. So no more x's in that third term. Okay, so that's factoring just the GCF out. And we're going to use that today to deal with some problems that get a little crazy. Okay, so if you're being asked to factor by grouping, okay, if you see something like this, 6x squared minus 42x minus 15x plus 105, those numbers are a little crazy, and while you still could do it, one thing that's going to help is I want to check to see, do all 4 of these terms, all 4 of them, before I split it up, do all 4 have something in common? Okay, so let's start with the smallest number, 6. 3 and 2 both go into 6. There's no exact science to this. I see 6 and I see 15. The only number that goes into both 6 and 15 is 3. So I'm going to check to see, does 3 go into the other numbers or the other coefficients? So 42 can be divided by 3. And then I'm going to also check 105. And that also can be divided by 3. So that means what I can do here is I'm going to take a 3 out of, now, this is not me splitting up the problem, okay? I'm going to take 3 out of all 4 of the terms. Every term is getting divided by 3. So 2x squared instead of 6x squared. This is minus 14x. This is minus 5x. And then this is plus, I erased it. What was it, 35? 45? 35. 105 divided by 3. 35. Okay. So I've taken out the GCF, but I still have 4 terms in that in the brackets here in black. So I'm going to go ahead and do factoring by grouping. Just so I don't forget, I'm going to put, every time I start a new line, I'm going to put my GCF of 3 with these giant brackets, just so I don't forget about it at the very end. Okay. So now if I take this problem and split it down the middle, what do the first 2 terms have in common? 2x squared minus 14x. Well, I can take a 2 and an x from each of those, okay? And that would leave me with x minus 7. And then over here, so I'm moving to the second half of the problem now. Because the 5, because the first term has a negative 5 in front, I'm going to factor out negative 5 as part of the GCF. And if I divide both of these things by negative 5, I'll have x minus 7, which again is what I want to see. I want to see the same thing in parentheses for both halves of the problem when I split it up. Okay, now I'm going to go ahead and take this and move it down just a little bit because now I'm ready to write my answer. So my two factors are going to be x minus 7, which is the parentheses, the common parentheses on both sides, and then 2x minus 5, which again, just a quick review, when you're doing factoring by grouping, the two GCFs will come together. Okay, now these big brackets that I made are kind of unnecessary. So to kind of clean this up and make it a little sleeker, I'm just going to put the GCF of 3 in front of the first factor, 2x minus 5. Okay, so there's a lot of greatest common factor stuff going on here. But if you can take a number out of every term, all 4 of them, we want to do that because then the numbers are smaller and easier to work with. Okay, so let's look at one more example. You'll try one and we'll just be done with this video. So I see 4, 12, 16, and 48. I know for sure 4 goes into 12, and I know for sure 4 goes into 16 or multiplies it into 16. Double checking 48, and 48 does work. Because I have a negative 4 in front, I am going to take a negative 4 out as my GCF. Okay, so if I divide everything by negative 4, I have x to the third plus 3x squared now, because negative 12 divided by negative 4 gives me positive 3. Instead of minus 16x, I have plus 4x, and instead of minus 48, I have plus 12. Okay, so now that I have those, I'm going to go ahead and ignore the 4 for now, that GCF, and I'm just going to look at these, just do my factoring by grouping. So x to the third plus 3x squared, I'm going to take x squared from each of those terms because I can take 2 x's from each, and that would leave me with x plus 3. And then over here, I have, nope, let's go red. 4 can be divided from both of these terms in the second half of the problem, and that would leave me with x plus 3, which is fantastic because that's the same as the front half of the problem. So x plus 3 times x squared plus 4 with a negative 4 out front. And we're done. Okay, so that's our whole factored version. So really it's just about if you can take a number from all 4 before you split it up, go ahead and do that. Pause the video quick, try this problem. There is a GCF, so start there and then we'll wrap this up. Okay, so these 4 terms all end in 0s and 5s. So that means 5 is going to be a GCF. And 5 is indeed the biggest number because I can't take 10 from all 4 of these values. So 5 is going to be my what I divide every term by. So this gives me 6x squared plus 15x minus 2x minus 5. Okay. So now again, I'm going to kind of zoom in and just focus on what's inside the brackets here. And now I'm going to split and go. 6x squared plus 15x. 3 divides both of my coefficients. X can come from both terms, so then I have 2x plus 5. And I can, right now, like as I'm going through this, I know I'm working towards the correct answer because I see 2x minus, or some variation of 2x and 5 on both sides. Okay, now here I can't just keep the parentheses the same. I do have to take out the negative from both of these terms. So I'm going to put negative 1 as my GCF, which would then turn both of these to positive, which now my 2x plus 5 matches on both halves. So we have 3x, nope. The order doesn't matter that you put these in. I just want to stay consistent. 2x plus 5 is my first factor. 3x minus 1 is my second factor. And my GCF that I took out in the beginning of the problem was 5. Okay. So that's the you try. Okay. Summary, how can I factor by grouping if there's a GCF? Check for GCF of all 4 terms first, then factor by grouping. And we're done. So we got 2 more sections and then we'll wrap up chapter 8.